Hello friends, in this video I am going to explain two important numerical problems based on Coulomb's law. In my previous video I explained the Coulomb's law. There I said that the force between 2 point charges does not depend upon the medium between them, but the net force depends upon the medium. So these two problems, J questions, previous exam we got these questions, very important, listen carefully. The question number 1, find net force on charge at origin. At origin charge is 1 coulomb due to other charges. That means here 1 meter distance charge is mentioned 1 coulomb. Next one means 2 meter 8 coulomb, 27 coulomb. Like that, at 10 meter distance the charge is 1000 coulomb. So we have to calculate the force on charge at origin. Let us see. So it is mentioned like this. This is the origin. This is 1 meter. 2 meter, this is 3 meter, like that. This is 10 meter. Here is 1 coulomb, 8 coulomb, 27 coulomb, like this. This is 1000 coulomb, like this it is given. So we have to calculate the net force on charge. That means how much force is acting due to all these charges on this charge. Here this is the origin. Here the charge is taken 1 coulomb. Now let us see the force on 1 coulomb charge due to this 1 coulomb charge which is at a distance 1 meter from the origin. So definitely the force will be act like this way. Okay. So now I can say that this F1 is equal to, according to Coulomb's law, 1 upon 4 pi epsilon naught Q1 Q2 by R square. Otherwise I can take it K Q1 Q2 1 into 1 divided by R square, here to here 1 square. That means this is equal to K. Similarly, I can take that F2 is equal to K 1 into 8 divided by here to here 2 meters 2 square. That means K into 1 into 8 divided by 4. That means this is equal to 2K. Similarly, I can calculate that F3 is equal to K into 1 into 27 divided by 3 square. Means this is 9. Means this is 3K. Like that. So we can write that the total force is equal to F1 plus F2 plus F3. All these forces will act like this. Suppose F1 is like acting like this, F2 also will act like this, F3 also like this. Okay. So F1 plus F2 plus F3 up to here 10 meter. That means F10. So I can write it as K plus 2K plus 3K up to 10K. Or I can write that K into 1 plus 2 plus 3 up to plus 10. Sum of the natural numbers 1 to 10. That means K into 10 into 11 divided by 2. That means this is equal to 55K. Clear? So 1 plus 2 plus 3 plus up to 10. So 10 into some of the natural numbers written. I written 10 into 11 divided by 2 into 5, that means 55 K. So this is about the net force on charge at the origin. So I hope that you understood this answer properly. So I am rubbing it. Moving towards the second question, which is also similar type of question. Both questions based on Coulomb's law. Now, in the second question, what is there? Here in 1 meter distance, 1 Coulomb charge there. Here minus 2 Coulomb charge, plus 3 Coulomb charge. That means alternately it is given up to the infinity. We have to calculate the net force on charge 1 Coulomb. Okay. So here the force will be, suppose F1. The second force will attract, that is F2. Like that it is mentioned. So now you see that F1 K Q1 Q2 by R square according to Coulomb's law. So I am taking K Q1 Q2 divided by R square 1 square. That means this is equal to K. Now F2 is equal to K. Here is 1. Here is 2 divided by 4. So in this case, I can take this as minus. So I can say that this is minus K by 2. Similarly, suppose F3, this is K1 into plus 3 divided by 9. That means this is equal to K by 3, like this. So now we have to calculate the net force acting on the charge 1 Coulomb. So I can say that this F equal to F1 plus F2 plus F3 up to infinity it is given. So I can say that here I can write this is K, this one is minus K by 2, this is K by 3, again minus K by 4, like that infinity. So if I take common K, it will be 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 up to infinity. So we know that in natural logarithm ln 1 plus x is equal to x minus x square by